Today we will be graphing proportional relationships. The number of tiles Zion needs to put on the wall to make backsplash is shown in the table. Determine whether the number of tiles is proportional to the number of rows by graphing the relationship on a coordinate plane. Okay. Now, when we are talking about proportional relationships, when we have this point here, 0, 0, and our table increases at a constant rate. So this is 7, 7, 7, and 7. And this goes 1, 1, 1, and 1. So this is a rate of change of 7 over 1. That change in y is 7, change in x is 1. So that rate of change is the same throughout, and it goes through the points 0, 0. So this is proportional. Okay, now in order to graph this, we are going to look at our x and our y as ordered pairs. Okay, so 0, 0 would be the point 0, 0. 1, 7 is going to be 1 as your x, 7 as your y. Okay, and we are going to come down to the graph and we are just going to plot these points. 0, 0. Okay, 1, 7 is 1 on your x, 7 on your y-axis. Okay, 2, 14 is 2, then 14, 3, then 21, 4, and then 28. And we plotted points at each of those places. Then we are going to get a line here, and we are going to graph it like this. Okay, and that line is going to continue in that direction. Okay, so this is how we graph a proportional relationship when we are given a table, is we just turn these points into ordered pairs and then we plot those points. Okay, now when you're looking at a graph, we can tell it is proportional by two things. First, it's a line. It's a straight line. And then second is that it goes through the point 0, 0. Okay, now sometimes eventually we are going to end up with a 4-quadrant coordinate plane here. And this line would continue in the opposite direction, going into the negatives. Okay, so this line is going to actually extend in both directions. Now, in the context of our problem, that doesn't necessarily make sense because you can't have a negative number of rows or negative number of tiles. Okay, but theoretically, if we were to graph the whole line, this is what it would do. Okay, and it is proportional because it is a straight line and it goes through 0, 0. Okay, so let's take a look at this second one here. The table shows the perimeter of a square based on the length of the sides. So again, it has this point 0, 0, so that checks off one of our boxes. Okay, it's going to go through 0, 0. And a straight line means it has a constant rate of change. So we go 4 over 1, 4 over 1. Those simplified to 4 over 1. These are all the same rate of change. So this is, yes, going to be proportional. Okay, and we'll come down and we'll go ahead and plot these points here. 0, 0 will be my first point, then 1 and my x, 4 on my y. Notice that these actually, each of these grid marks is half. Okay, so make sure you pay attention to those axes and what they count by. My vertical axis, my y-axis counts by 2, 4, 6, 8. See that? Okay, so you're not just counting boxes, you're paying attention to the way that the axes are labeled. Okay, 2 and then 8. Okay, 3 and then 12, 4 and 16. That's also going to be really important when we start looking at that rate of change from the graph. See how we talked about it's a 4 and a 1? So here to go from 4 up to 8 is a 4 the change on my y is 4. And then to go from 1 to 2, this is a change of 1 on my x values. Okay, so you can kind of see that there. That's a little view of what is to come eventually. And then we finish our graph. We draw our arrows and we are good to go. It is a proportional relationship. Straight line goes through 0, 0. And here are 2 more that you can try on your own right there.